Of course, you have heard this already. So, my name is Daniyal, and today we are going to talk about the picture of our universe. And in my perspective, it is very essential one. And you have no even clue how it affects you, how it just simply influences you. And for that, we are going to just simply, take simply some lessons for physics, and we are going to go through certain series of theories which are basically done by our predecessors. And we are going to talk about how things work out, how things are stuck, how things can be correct, perhaps. So there are multiple questions to think about. That what is universe? Actually, the person who is stuck in uncertainties, he knows the best. Like, what the hell is the universe? You really have to think about it. So, and uncertainty sucks, seriously. So, in this framework of my talk, I'm going to go through certain theories like Newtonian physics, Maxwellian physics, Eistenian physics, quantum physics, and a bit of string theory. And that's it. 300 years of work being done in 10 minutes. Yeah. I'm super unqualified for this. First of all. So, of course, for anybody here who has not studied physics yet, does not study physics. So, what is physics? And actually, it is the basic science, the most important science ever existed this far, in the world of science. So, the realm of physics is concerned with physical quantities. It is about how nature works, what makes the nature works. I mean, why the hell he is sitting there? What makes him sit there? We don't know it exactly. Although we know it to a certain computational structure, which is called mathematics, but we exactly don't know. So that you can think about, when you can think about it, how he's sitting there. Then you can think about this legend. I love him. His name was, and his name is, Sir Isaac Newton. Very, very smart person, the most smartest person ever lived on this planet. And he invented calculus. Most of us studied that thing. So, that dude sort of invented the three basic laws of motion, which with certain construct, I can tell, why he's sitting there, I can tell why you're sitting there, I can tell why you're interacting with me, I can tell why my voice is, getting delivered to you. So, I can tell a lot, but I don't know. I'm uncertain. So, going forward, Newton basically just proposed, universal context. In context, simply postulates. He said, look guys, for you, for me, time is same throughout the universe. It doesn't matter where you are standing, it doesn't matter on which planet you are, it doesn't matter which universe you even are. And actually, his theories had great prominence. Therefore, they are the sort of the copying machine like physicists simply just accepted the idea. Okay, the time is universal throughout the universe, and further, other postulate the distance in context to relative motion doesn't change. So, along with, we must thus far study Newton's law, so I'm going to touch a bit. So, if I'm standing here, the reason being is that, nothing is exerting force on me to move. Perhaps things, force are getting exerted on me, but in my cognition, I'm not getting forced to move, which we call motion, movement, the displacement, being forced upon by certain force in order to move and accelerate. So you then can think about me if I'm standing here, and perhaps you should throw me into space, and you're gonna go throw me very far. I'm gonna go forever. I don't know how far I'm gonna survive. My matter thing. So yeah. So you can think about Newton's laws, and you can think about the molding of three laws. And the second law is just simply that I'm standing here and you exert force on me and you're going to accelerate me. So Newton, molded these two basic laws, and he sort of came up with the action and reaction law. He said, okay, provided there's a certain objective, you're going to exert force on it, it's going to exert force back on you with a simple not simple, but same and equal and opposite force. So then, he was very smart. He was very smart. So he sort of, molded these laws together, and he sort of came up with universal law of gravitation, which is actually incorrect. But the sort of mathematical structure he had, it exactly predicted the planetary motion of the Mercury was wrong actually. Jupiter, Saturn, and all we know this far, our solar system. So further going into Newtonian physics, we are just going to delve off into Maxwellian physics, and we are going to talk how this theory fails, because this theory now is incorrect. Perhaps it can be used this far from my empirical experiences. I can tell you exactly how it is correct as far as my empirical experiences are concerned. But this fails as we go fast, and fast. So going further, come on, work. Yeah. So going further, along came Maxwell. I love him also. I think so. He was the most smartest person I ever learned, because the work he did was very complex, very complex, but very beautiful. So he basically said that provided that he worked on electromagnetism, and he said provided that you are given certain two fields, different fields. First field changing magnetic fields, other changing electric field. He said, look, if you sort of just look and imagine, okay? So he said that this changing magnetic field can cause and induce certain changing electric field. And then he further said, I can definitely prove this, and any physicist or any student of physics can prove this through Maxwell equations, that you can sort of make a certain oscillation through these electric field and magnetic field, and they are. So basically the thing is that magnetic field causes an induction in order to cause electric field, and that further proposes into that changing electric field can cause changing magnetic field. So you can see there a sequence of oscillation being formed, and then you can think about it that because then you can think about it, because if this thing can go in certain consistent constant progression, then I for myself can think of certain new thing, and of course which Maxwell did, and he sort of invented the electromagnetic wave, the constant speed of light, and that is very important for me. That is important for any physicist. That is important for any physics. That is important for every individual of you, even if you don't know how it is worked. Anyway, so this paradigm shift, this is very important, because it changed everything, and I'm astonished about to think about it, how it affects my life, seriously. And I don't know exactly, because it deceives my perception, my senses. So going further on, so we talked about the constant speed of light. Then of course, a very smart person, I love him a bit. So Einstein sort of figured out certain contradiction between Newtonian physics and Maxwellian physics. He said, how come something in certain inertial frame, if going provided at certain speed, cannot be influenced in certain space-time geometry, and many other views, which we are going to further delve into the special relativity. So special relativity is concerned with inertial motion. Inertial motion, that's why it is special, because inertial motion is where there is no gravity, there is no force, okay? So perhaps there is one force in which the object is going, but we are concerned with it is in inertial context, okay? So then Einstein sort of invented amazing ideas, beautiful ideas. He said that, look, provided that me here, if you are gonna throw me up to the speed of light, I'm seriously gonna shrink, and my weight is gonna, I'm gonna lose a bit of weight. And it's sort of if you start throwing me again as being a beam of light towards another planet, but I'm gonna come back. One situation is either you're gonna be dead, or either we gonna have 90 years, 120 years, I don't know. But perhaps there is reasonable mathematical structuring behind it which can definitely prove this. And we have proven this. I mean, I love physicists and they've proven this. And so So much love. So further going on, then we can think about other ideas like length constriction, which of course I said I'm gonna shrink, my weight is gonna lose. So Einstein sort of took this idea, he sort of went with this special relativity in inertial frame of reference, but he again went with Newton, and I love this thing because this thing is gonna change your view of the upcoming universe, which you don't know, which nobody knows. But because this theory has certain structure which is really gonna change things, I doubt that, because I doubt that it is in positive, it is gonna change things. So it is the basic idea about space, mass, time, and that stuff, the basic quantities we know in physics, okay? So this idea sort of explains the structure of universe, the structure of space. Perhaps not exactly the structure of space, but it explains, why gravity exists. Actually, you know what? Gravity is not a force, it's a feature of space-time. You are deceived in Newtonian physics that gravity is a force. It's not a force. I can't prove this. But mathematical structure proves this. I can prove it. So this sort of theory had a lot of consequences. It brought along amazing things like you all guys see eclipse, which is a solar eclipse. Then you see different stuff like you don't see different stuff like this, like gravitation shift, red gravitation shift, red shift. So. There are other ideas like equivalence principle, which is like if I'm standing here and like this, now gravity is influencing me. If I'm going in certain acceleration, then of course there's acceleration happening. So there's no difference between gravity and acceleration. So now this very important theory sort of also brought along, Einstein was a crazy person, He sort of invented one thing, he sort of invented other thing, which was totally in contradiction. So, quantum physics and relativity going along in contradictions. So why is that so? Because the founding father of the quantum physics is Albert Einstein. He sort of invented the photoelectric effect. It is just simply like that. Why there's a certain metal here, and if you just simply shine certain beam of light on that metal, it is gonna, eject electron. The metal is gonna eject electron from its surface. And there are multiple reasons behind it. But from that point, you can think about it, that led to a paradigm shift. And further going, and actually, scientists sort of stuck here in wave and particle duality. And there is a lot of reasoning and a lot of argumentation behind it. We are not going to delve into it. So, which I think, afterwards, this amazing discovery, scientists sort of, got involved in certain math. And I love that math. It's interesting, perhaps tedious. Why? Because, they sort of invented and discovered, hundreds of particles, not, ending up at certain conclusion. And you simply are going, you're going up here, you're cutting things up with certain, particle colliders, and you are ending up at no conclusion. So, okay, I'm eating up my time. I'm just gonna skip that, but there was one important point, which is Heisenberg uncertainty. I'm gonna involve it in here. So now this theory is very important, okay? I expect myself to work in this in coming future, if I were to be alive otherwise, and I love this thing. I really love this thing, except anything else. So this theory is sort of unification between everything. Like, if this theory can explain anything, perhaps this theory really can explain anything. What are you? What is this person? What the hell is everything? What the hell is going on? And seriously, this theory can explain because of its multiple properties. Like you are sort of combining the micro world and the macro world together. Saying, see, if you compose two theories together with their defining properties and postulates, you can get certain idea about matter, how it comes to its existence, and how it further exists in space being going in certain motion. Perhaps I don't know what I said now. So So then we think of different ideas. Okay, so I'm running out of time, so I'm just going to skip very quickly. These are very important things, but perhaps. So extra dimensions, brain, deep brains, these all things derive from one's fundamental concept. The fundamental concept is that Einstein, before scientists, thought about fundamental particles. Okay, now they are thinking about fundamental strings. They say, fundamental particle is a zero-dimension object. But now they are thinking about strings as one-dimensional object, so they can relate to it in contextual geometrical structure, and they can definitely prove this. But they're again making mess. So because they're making things complicated, and complication leads to multiple uncertainties. So let's delve into it and impart. Okay. So in a minute or so, I'm going to summarize this whole thing. Okay. I told you everything. I never told you everything except some things. There's a lot of work into it. But so I'm thinking about now uncertainty. I never told you anything in context of certainty in this thing. But whatever I told you, I sort of contradicted everywhere myself. I said this person said this person said this is saying wrong, this is saying right, this is saying wrong, this is saying right. A lot of mess. So the thing is that we don't know what exactly the picture of the universe is. What everything, how can we explain everything in certain equation? How can we explain everything in certain quantification? But we don't know, because we are very uncertain. We are very inconsistent between our predecessor theories, our existing theories, and the theories in previous 100 years. So the thing is that there are now people who are struggling to work out stuff, who are thinking about things, how to improve things, how to get to a certain ending point, and that's why we are talking stuff like this. Perhaps I'm nothing in context to physics learning. I'm a very small object, but we are talking stuff, which is very important. Talk is the most important thing. It is the objective to begin. You don't need to where you want to end. It is the objective always to begin. So that's it. I hope I was now not very uncertain, because I think I was very inconsistent. Perhaps anyway, doesn't matter. So, I'm sweating